Okay, for my students who are taking any um, elementary algebra or intro to algebra um, course at the college level, here we go. This is rational expressions, and it's simplifying rational expressions. And basically, when we're talking about rational expressions, we're talking about fractions that are polynomials. They're usually called rational expressions. So here we go. It actually says here a fraction in which the number and denominator are polynomials is a rational expression. So I'm not going to burden you too much with words. We're going to get right into problems that you will see. So these are the type of problems you will see, and I'll get right into simplifying them. And the reason why I'm saying simplifying and not solving, it's because these are all expressions. There's no equal sign. There's nothing to solve here. So I'm going to start with the first question, which is outlined there for you. That's 15a to the 8th power b to the 4th power, 20a to the 10th power b. All right, so here is how I like to simplify these rational expressions. I like to isolate or separate my common factors. So when I say common factors, I mean my constant factors. I'm going to separate my A factors, and I'm going to separate my B factors. Good, and now I'm going to work out my problem. So one of the best way I always tell students when it comes to dealing with exponents, when in doubt, expand. So I'm going to do this like about 2 ways, right? So the one of the ways is the dubious way. If you're not sure, if you haven't had enough practice, you're not confident in simplifying rational expressions, the best way would be to expand all your factors. If they're constants, break them down into prime factors. And if they're variables, just break them down into the powers, right? This exponent is telling you how many factors of A I have. So I can break 15 down into 3 and 5. These are prime factors of 15. And 20 into 2 times 2 times 5, because 4 times 5 is 20. 4 is still composite. I break them down. And then here, I have 8 factors of A. And I have 10 factors of A. I know what some of you are thinking, like, what? What if I had 20? Yes, so I'm going to get to that in a minute. So I have 4 factors of B, and I have 1 factor of B. And then as we know, we're going to cancel out common factors or divide them out, because when you have common factors, you really have a remaining factor of 1. So here, 5 divide 5 is 1. So those cancel out. So I'm left with just 3 over 4. Up here, I have 8 factors of A that I can match in my denominator with 10 factors of A. 1, 2, 3, 4, 5, 6, 7, 8. So I'm left with a factor of 1 at the top and two factors of A at the bottom, which will be A squared. Here and here, I only have 1 factor of B matching a 1 factor of B in the denominator. So I'm left with 3 factors of B, or B cubed. So now my remaining factors in my numerator, 3 times 1 times B cubed, which is 3B cubed. And the remaining factors in the denominator is 4 times A squared times 1, which is 4A squared. And there is no doubt about it that this is the simplest form that this can be in, because you broke down all the factors in the beginning to begin with to see that. Now, this method is safe but brutal if you have several factors of your base, right? If there was like 50 of it and 100 of it, who wants to expand A 50 times and 100 times, etc.? So you have to be familiar with your rules of exponents when operating with rational expressions, right? That with polynomials. So here I'll do the problem in a second way. And if you had looked at the video with the rules of exponents, we hope that you remember, well, we know that we can still separate. We can still separate our common factors just to, play it safe, right? So we know that the common factor between 15 and 20 is 5 if your table games is really good, right? 3/4. Or you can break them down into prime factors also and see what's remaining factor. And we know that if you subtract, this is a to the 8 minus 10, because when you have the same, when you're dividing exponents with the same base, you subtract powers. And this is b to the 4 minus 1, right? You subtract the exponents when dividing. So here we have 3/4 a to the negative 2, right? Times b cubed. And what do we know about negative powers? Is the reciprocal raised to the positive power. So this is 3/4, right? We're going to reciprocate. So that's really 1 over a squared, all right, times b cubed, which leaves me with 3b cubed over 4a squared. Isn't that beautiful? This is so much beautiful. Once you can apply your rules of exponents. Another little trade secret is that whenever you are dividing bases, right, similar bases, wherever the larger power is where your factor will remain. So for example, this is a10. A10 is in the denominator, so my base a remained in the denominator. If we look at b to the 4th power was in the numerator, so when I'm finished simplifying, you see where b remained in the numerator. So there's another way of looking at it to avoid working with negative powers. All right, so let's move on to the next type of rational expression that you'll see that you have to simplify. So this is just when it's like in like just looking in this format. Now here we have a format, number 2, where it looks like we have quadratic expressions. And how do we simplify these rational polynomials? So to simplify rational expressions like this, where you have terms as your numerator and terms as your denominator, you cannot simplify rational expressions that are terms. So for example, you can't say 18 divided 36 is 2 and x squared cancel. You cannot simplify rational expressions when it is in the form of terms, right? Terms meaning I'm adding or subtracting. They have to be in factored form. Must be in factored form to simplify. So how do we convert terms into factors? If you remember in previous videos, I defined factoring as converting terms into factors. So the good news is at this stage of the game, you're a beast at factoring. Yay. So clearly this looks like a difference of 2 squares because we have 2 terms being subtracted, and I can find the square root of these terms, which would be x and 6. So according to my difference of square formulas, I'll have x plus 6 and x minus 6. That would be the factored form of x squared minus 36. And if I look at my expression here, clearly I'll see that this has to be factored. And thank God that the leading coefficient is 1. So if I could just find factors of my constant that will equal my middle term, because it's positive, I know I'll have to do an addition to get the middle. I can see that 6 and 3 will give me 9, positive 6 and 3, so that my remaining factors here will be x plus 6 and x plus 3. And remember, it doesn't matter which side it's on. Multiplication is commutative, okay, which means you can set it up vice versa, okay? So here now I can simplify. Here I have a common factor of x plus 6 in the numerator to match a common factor of x plus 6 in the denominator, and I can cancel that remaining factor of 1. I don't need to write 1 times x minus 6. That's redundant, but my remaining factors now is x minus 6 over x plus 3. Done. All right. So So here we go. Let's take a look at another one that I'd really like for you to see. Here we have the expression 7 plus 6x minus x squared. And we have the expression at the bottom, 2x squared minus 13x minus 7. Now here's a little cue for you. You want your leading term to, you want your expression in order of hierarchy, meaning the x squared comes first, so, and the constant last. So here I'm going to start. This is negative x squared, right? These are classic problems to pay attention to. Plus 6x plus 7. And just rewriting the expression at the bottom. And another thing you want to note is that you don't want to work with your leading coefficient being negative. So what you want to do now is factor out a negative. What am I doing? That's a 7 minus 7, not 17. Right? So now I want to factor out a negative 7 in this expression up here because you don't want to work with your leading coefficient being negative. So I'm factoring out a negative 1, which means it'll change all the signs of my terms. So my new expression will look like this. All right. With that negative 1, I'm left with 2x squared minus 13x. So that remains the same. Now I'm going to look at my bottom. Remember I said that I cannot work with, I cannot cancel out terms when working with rational expressions. Can't cancel out terms. They must be in factored form. So now I'm going to, just as I've done in my first, the problem before that, I'm going to try to factor each of these expressions and see if there are any GCFs between the two of them. So don't forget my negative 1. So yes, this is a negative 7. My C is negative 7, leading coefficient of 1. So I know I can find factors of 7 that will give me negative 6, which would look like 7 and 1. So it'll be x minus 7 and x plus 1. And obviously, if you don't understand how I got that, you really need to stop this video and go back to look at the factoring video stages 1 through 6 to get an understanding of how I came up with that. And at the bottom now, I'm going to look to see if I can factor anything initially to see if I can make my leading coefficient 1 to make things simple, but it doesn't look like that. So now I'm going to be using my actual AC method to factor out this expression at the bottom. So it's really going to be 2 times 7, negative 7, which will give me negative 14 or negative 14x squared, you know, just working with the coefficients because it works out in hindsight. And clearly I can see that negative 14 and positive 1, right? Well, if I subtract them, will give me negative 13, my middle term. So now I have my 2 factors that's going to replace my middle term because I'm going to actually turn this trinomial into 4 terms so I can factor by grouping. Factor by grouping. So no longer can I do the shortcut and go from here to here. I'll actually have to factor by grouping when the leading coefficient is more than 1. So now my new expression is 2x squared minus 14x plus 1x minus 7. So I'm going to create my 2 groups by default. All right. I don't need to write 1x, it's redundant. And then I'm going to factor my individual groups, finding the GCF for each group. So my GCF here is clearly 2x. And I'm left with x minus 7. And since they have no common factor, my GCF is just 1. I'm left with x minus 7. And now I can see I have a common factor of x minus 7 and 2x plus 1. So now I can rewrite my expression in factored form, which is negative 1 times x minus 7. Remember, we factored out that negative 1 initially so that our leading coefficient don't be a negative, right? X plus 1. And my new expression at the bottom is x minus 7 over 2x plus 1. So I can see they have a common factor of x minus 7 that I can cancel. So my remaining expression in simplified form will be x, negative 1 times x minus plus 1 over 2x plus 1. I cannot cancel anything here because this 1 and 1 are terms, they're not factors. And x plus 1 and 2x plus 1 are not common. So this is my final answer. All right. So that's it. Give it a shot. And if you have any questions or concerns, you know how to find me.